Chapter 4, Problem 5. Your body temperature is about 300 Kelvin. At what wavelength do you radiate most strongly? What region of the electromagnetic spectrum is this? Do you understand now how a rattlesnake can bite you in the dark? So, we have your body, which is a particular temperature. All objects emit radiation, forms of light, including human bodies. They glow, but not invisible light. To relate the temperature of the object to the wavelength of light that it most strongly emits, we use Wien's law, which is that the temperature of the object is related to the wavelength of light that it most strongly emits. According to this formula, 3 times 10 to the 6th, that's a factor of 3 million kelvins times nanometers, and divided by the Greek letter lambda with an M subscript. Lambda is used to indicate the wavelength of light, the spacing between the crests of the waves. The M is to indicate this is the wavelength most strongly emitted by the object at that temperature T. Here we've been given the temperature and we're trying to solve for the wavelength. So if I multiply both sides of the equation by the wavelength, it cancels out there. Divide both sides of the equation by the temperature, so it cancels out there. We get that the wavelength is 3 million kelvins times nanometers divided by the temperature T. In this case, for the body temperature, we put in the given 300 Kelvin. The math is straightforward there. 3 million divided by 300 gives 10,000. The Kelvin temperature units cancel. It's 10,000 nanometers. Now, nano is 10 to the minus 9, just fractions of a meter. So this is a lot of small fractions. We could convert this to meters. One nanometer, nano stands for 10 to the negative 9, a billionth. So 1 nanometer is the same as that. This is a factor of 1. It converts from nanometers into 10 to the minus 4 meters. That's 0.0001 meters. And that works out to be the same as 0.1 millimeters. Mill is 10 to the minus 3. So this is 1/10 of 10 to the minus 3, 1/10 of a millimeter. It could also be written as 100 micrometers, micrometers, where micro stands for 10 to the minus 6. And I went through the work converting these different things because I was trying to answer this extra part of the problem. What region of the electromagnetic spectrum is this? On figure 4.20, page 110 of the textbook, was a chart showing the entire spectrum of electromagnetic radiation with various wavelengths, and 100 micrometers appeared to be in the infrared part of the electromagnetic spectrum. So human bodies emit most strongly in infrared radiation. You may be familiar with the idea of the infrared cameras used to detect the glow of body heat from people, to find the fugitives running away at night, that sort of thing. So it's not surprising that we got infrared radiation for the humans. And the last part of the question, do you understand now how a rattlesnake can bite you in the dark? The rattlesnakes have eyes that can detect infrared radiation. They can see this glow of infrared light from you. They can see you in the dark. What to us is dark, to them you shine brightly. And that explains why they can find prey like your human toes in the dark of night.